Hey, I'm Dan Sackels. I run business development for Brilliance RGB for the Americas. And we're here at Display Week showing our laser chip technology. So what Brilliance has developed is a fully integrated RGB laser light source where we incorporate individual red, green, and blue laser dye flip chipped onto a silicon substrate. And each of those beams are combined together to produce a single white beam or spot that has the ideal properties for minimizing insertion loss and projecting through the rest of an optical system, whether that may be projecting onto an LCoS or a laser beam scanning MEMS, and being used with a waveguide display technology.
And demonstrator is available now?
Yes, we have. Right now, we are shipping our evaluation kit, which incorporates our laser light chip and a driver and the software for the user of this to experiment with adjusting the beam properties and so forth.
And so it's very brilliant. How's the brightness?
Brightness is how many lumens? We are producing, let's see,
is it one of those?
Lumens. It depends. Yes, this is Neptune 1. Neptune 2 is just coming out. It's going to be able to support up to 100 milliwatts per color, and the first Neptune is up to 20 milliwatts per color.
Does it depend on the color, which the brightness is? Like some of the colors brighter than others?
Naturally, the laser dye has different levels of efficiency, so each one has a different efficiency.
And when it's RGB, that means the green one is brighter or not? No. Oh,
so I don't have my.
Sorry, I shouldn't ask too much. Yeah. But also when it's here, it can help.
So this is a concept. Okay, this is not a product. That's just an artist's conception, illustrating a super small modular light source for an AR display.
So you could, when you show this, for example, where are you on the dot? Where do you?
We can be everywhere in this square.
So I see.
The point here is this Brilliance and our laser chip technology can fulfill the requirements for virtually all AR displays.
And so you help the micro LEDs?
We're not micro LED. We're an alternative to micro LED.
Alternative.
Right.
Okay. So it's really good for LCoS.
That has advantages way and above what micro LED is able to produce.
For example, when I see that Meta over there is showing, just behind you actually, is showing an LCoS based on the market, is sold out, and it's people seem happy with it, but you can make it even better?
Absolutely.
So you can make it, what? More brighter for less battery power, a smaller device?
Brighter, lower power, more efficient, and achieve an all-day wearable design that's daylight viewable. And if you look at what Meta's doing right now, it's a great step forward, but it's still single channel.
One eye only?
Yeah, single eye. Yeah, single eye.
Single eye?
Yeah.
And it would be nice if your glasses could fit something like that.
Eventually they will. Eventually they will.
And I don't mind having a power bank in the pocket, actually. I don't mind, or swapping some battery or something, just lasting longer.
Well, that may be, but most people will not tolerate that.
That's a different question. Is that it? What are you showing here?
So this is a mock-up of a next generation chip that's going to be a flood illuminator so that laser can be used to solve the problem of illuminating LCoS displays. So this will be an LCoS flood illumination solution. There's two variants for that, where the Neptune family is a point source. It's a single beam. Originally it was conceived for laser beam scanning. So this is our partner LMJ who provides the MEMS and quickly integrated our laser chip with its MEMS MEMS scanner to produce a laser light projector.
And this full color.
And it's full color and super saturated.
Could this be in the very high frame rates also?
I don't know the specs for it.
Yeah.
Yeah.
How does it compare with, for example, Vitrea Lab might be showing?
So Vitrea is a partner of ours as well. And so Vitrea solves the problem, they too solve the problem of reshaping the beam so that it can be projected to cover an LCoS panel. So we're working with Vitrea.
So you say USA, where's the company based?
Company's based in the Netherlands, in Enschede.
All right.
Yeah.
Okay. How soon is this technology could be in mass production?
So it's already in production. The mass has not arrived yet, but we and the entire supply chain are in the process, like everybody else, of ramping up. Luna is going to be out. We expect to be sampling the Luna chip for LCoS in the September timeframe. But we are shipping for those who are interested in starting to experiment with the point source solution. Neptune is available today.
And if you experiment with this and you get this kit, what can you do with this? Can you do like modulate the colors like as fast as you want? Do all kinds of stuff?
You can modulate the colors. I don't remember what the specs are, but I can send you the data sheet if you're interested.
Imagine every pixel, every sound, enabled through HDMI technology. From the highest resolutions, the fastest refresh rates, to immersive multi-channel audio, HDMI technology powers a worldwide ecosystem of devices for movies, for gaming, for creators. Experience clarity, performance, connection. HDMI technology. Connect the future today.